So after this first part of mole, where we learn AR, MR, and percentage composition, actually we have not touched on the mole yet. Okay, so we always say this topic is mole, right? So actually what is mole? So why do we need to know this? Okay, so most importantly, mole allow us to connect whatever we learn to practical. So in the lesson that we have learned, especially under acids, bases, okay, we learn quite a number of reactions. But in reality, we need to know how much to react. It's like you bake cake, right? You don't just pour everything in and mix them together. You need to know how much flour, how many eggs to use, okay, how much sugar. So you need to weigh all these ingredients. Likewise, for chemistry, everything also need to weigh. Everything also need to know the mass. Okay, so that is why mole allows us to connect theories to practical. Okay, so what do I mean by this? Okay, so we're going to find out what is a mole. Okay, in chemistry, we don't look at one atom, one molecule, because they're just so tiny. We don't say one strand of hair, we just say hair, right? Okay, so same thing. Okay, we're going to take a look at what is mole and how do they connect, okay, to calculations on how much to use. Okay, so which of the following is a mole? Everything. The three pictures here, they are mole. Okay, mole is the animal mole. Okay, and the mole on your body, and of course, mole also can refer to a spy. Spy is a mole. All right. Okay. What is mole in chemistry? So let's take a look at this one first. Okay. Do you know what's a pair? A pair of pairs. So when we say a pair of pairs, we mean two pair. Okay, two items. And you know what's a dozen? When I say give me a dozen of eggs, you bring me 12, right? So pair and dozen, all these are units. Okay, for example, I say bring me a pair of chopsticks, you bring two, you don't bring one, right? These are the terms that we use to refer to quantities. Okay, but of course in chemistry, we don't say give me one pair of atoms, okay, because they are so small. Okay, so mole is also like these terms, okay, to describe quantities. All right, so page 6 of your notes. So mole is like a unit to tell you how much is the substance. Okay, so fill in the blanks in your notes, page 6. So the SI unit for mole is MOL. Okay, the full spelling is MOLE, but whenever we want to write down our answers, we use the SI unit, which is MOL. Okay, so for chemistry, okay, 1 mole refers to this amount. How many zero you count? 1, 2, 3, 4, 5, 6, all the way. Okay, so 1 mole in chemistry, 1 mole of particles, 1 mole of molecules refers to this amount. How long does it take for you to calculate until this amount? 1.9 times 10 to the power of 16 years. So let's continue. 1 mole refers to 6 times 10 to the power of 23 particles. Okay, so recap. When I say 1 pair means 2. When I say 1 dozen means 12. When I say 1 mole, it means 6 times 10 to the power of 23. Okay, remember this number. Okay, so 1 mole refers to 6 times 10 to the power of 23 particles. So this particle is very, very general. Okay, remember kinetic particle theory. Okay, when we say kinetic particle theory, we are talking about particle in general. It can be molecules, it can be atoms, it can be ions, it can be electrons. Likewise, it's the same for here. Okay, so this special number is discovered by this guy called Avogadro. Okay, it's Mr. Avogadro. Don't need to know how to spell. Okay, but don't tell me it's avocado lah. Okay, and so it's 6 times 10 to the power of 23 mole. Okay, so let's try this. Page 6 in your notes. So if I say, okay, 1 mole of iron, okay, it means 6 times 10 to the power of 23 atoms. Okay, if I say 1 mole of H2, okay, so H2 is made up of 2 atoms chemically combined. So atoms that chemically combine, they are called molecules. So I say in 1 mole of hydrogen, 6 times 10 to the power of 23 molecules. Okay, so let's try the remaining 3. Fill in the blanks. Okay, so do you get this as your answer? 1 mole of CO2 refers to 6 times 10 to the power of 23 molecules. Okay, so if it's Na plus is not an atom, it's not a molecule, it is an ion. Very good. Okay, so 1 mole of sodium ion, okay, means that I have a total of 6 times 10 to the power of 23. Okay, I remember when I say mole, it refers to a fixed quantity. So if I say 1 pair, One pair of Na plus means two Na plus ions, two individual Na plus ions. If I say 1 dozen of Na plus, it means 12 Na plus ions. If I say 1 mole, this 6 times 10 to the power 23 ions. So if it's 2 moles, then how? If I give you 2 moles of Na plus, so you will multiply by 2. Okay, so you will multiply by 2 and you'll get 1.2 times 10 to the power 24. Always expressed in your standard form. Okay, just like what you learn in math. Okay, so this is the mole. Okay, so whenever we use the term amount, when we say number of moles, we are always referring to this. Okay, we are not interested in the exact number of particles, but in general. Okay, we are always looking at number of moles. Okay, sometimes when we do our calculation, we will see it later on. Okay, when we do our calculation, we need to write statement. So when we write statement, okay, you can either choose to write these 3 words, number of moles, or if you are lazy, these 3 words, right, is actually equals to N. Okay, so when you write N, then you have the subscript CO2, it means that number of moles. Okay, we will take a look at it later when we do our questions. Okay, so let's take a look here. What does this picture tell you? Okay, this picture is trying to tell you that they are all equal, meaning the number of particles are the same. Okay, the numbers are the same. So for example, 1 mole of hydrogen, okay, in terms of atoms, okay, in terms of atoms is 6 times 10 to the power 23. Okay, 1 mole of carbon is also the same. The number is the same. Okay, so for example, if you really don't understand this, I give you an example. Okay, if I say 1 pair of apples, how many apples are there? 2. If I say 1 pair of eggs, how many eggs are there? 2. If I say 1 pair of birds, okay, how many are there? 2. So 2, 2, 2. 2 equals 2 equals 2. So they are the same. So same as this example here. Okay? Alright, so we have actually figured out what is this identity of mole. Then there's this next part called molar mass. What does molar mass mean? Molar mass does not mean the mass of your molar. Okay, I'm not referring to your molar teeth. Okay, so moving on. We have identified mole, but we have not really figured out how is this mole related to mass. You see? Okay, so recall this part here. Okay, neutron and proton, where we learn at the start of this lesson, okay, we know that the relative atomic mass is 1 unit, right? 1 unit. There is no grams, kilogram, or milligram. No units at all. Proton, we also know that it's 1 unit. Electron, we learn that it's negligible. That's why it can float around. It can fly around in the electron shell. However, they actually do have mass. Okay, I repeat, everything has mass. Solid, liquid, gas, they all have mass. And these solid, liquid, gas are made up of atoms. And these atoms contain subatomic particles. So everything has mass. So actually, neutron and proton and electron, they do have. Just that they are very light. If I want to say in grams, neutron and proton, they have the same mass. And what is their mass? 1.67 times 10 to the power negative 24. Okay, so of course, in chemistry, we don't really write these numbers because we don't need to remember. We don't want to remember so many numbers. We just simplify it as 1 unit. And this 1 unit is the one we compare with the carbon 12. Okay, if you don't understand this, never mind, it's okay. Okay, moving on. So we don't write all these numbers because they are very tedious. Okay, so we use relative atomic mass. But they do have mass. Okay, so in actual fact, neutron, proton, each of them is 1.67 times 10 to the power negative 24 grams. Electron is 0.0009 times 10 to the power negative 24 grams. Okay, so how many protons and neutrons are there in a single hydrogen atom? Look at your periodic table. What is the relative atomic mass? Okay, do you realize that there is only 1 proton? Okay, ask yourself. If the hydrogen only contains 1 proton, the atom only got 1 proton, what is the mass of 1 atom? 1 atom. So 1 proton is 1.67 times 10 to the power negative 24 gram. So, agree? Okay, that's 1 atom. So in chemistry, this is too small, too negligible. We don't look at 1 atom. We don't look at 1 single atom, we look at 1 mole. So 1 mole contains how many atoms first? Recall. 1 mole contains 6 times 10 to the power of 23, right? So each of them is 1.67 times 10 to the power of negative 24. Multiply. Okay, so multiply this. How much do you get? So if I was to erase this portion here, when you multiply them, do you get about 1 gram? Okay, you get about 1 gram. And I want you to compare. 1 mole of hydrogen atoms is actually 1 gram. And this 1 gram, is it the same number as the relative atomic mass of your hydrogen in your periodic table? Is it the same? Do you realize that they are the same? Same number, don't care about the unit. Same number, right? Don't believe me? We try one more time. Okay? Carbon 12. Let's take a look at this carbon 12. We always compare with carbon 12, right? So let's take a look at carbon 12. How many protons and neutrons are there for carbon 12? Look at our periodic table. It is 12, right? So total 12 protons and neutrons. Okay, anyway, they are the same mass, so I don't need to care how many protons, how many neutrons. How much does a carbon atom weigh? So 12 times 1.67 times 10 to the power negative 24. You get this? So this is one atom. Now I ask you, what about 1 mole? How many atoms are there in 1 mole first? 6 times 10 to the power of 23. Okay, so if I were to multiply to find out the mole, I get 12 grams. So what do you notice about this number? Okay, so we compare 1 mole of carbon atoms, the actual one, the actual mass, and the AR. What do you notice? You notice that they are the same, right? So actually, whatever you learned so far, I hope it makes sense to you. Okay, and so whatever we learned so far, there is a reason behind it, and this is how we get it. But of course, do you need to memorize this actual gram? No need, no need. Okay, this whole 2 parts is just to help you to understand AR and the actual mass. Actually, they are the same thing. They are the same thing. Okay, just that one got no units. Okay, so what is molar mass? The name molar mass means mass of 1 mole. Okay, and if you notice from the previous example, okay, the mass of 1 mole is actually the AR. Just that molar mass has unit. I repeat, molar mass has unit because we are looking at the actual mass. Okay, when you see relative means it's a ratio, no units, but when we see molar mass, it's an actual mass. Okay, so the unit is either gram per mole or gram mole to the power of negative 1. They're the same thing. Okay, okay, so molar mass for a molecule and ionic compound is also the same. Okay, so molar mass for an atom is relative atomic mass, molecule is relative molecular mass. Same thing, units, all the same. Okay, all right, so try some questions in your notes. Okay, fill in the blank. So first of all, water Mr by now should be able to calculate. Okay, 2 hydrogen plus 16 is 18. Okay, so molar mass is the same as Mr. Molar mass is the same as AR for atom. Okay, so you just write down. Okay, but take note, molar mass, I repeat, you will have the unit. Okay, molar mass has the unit. Alright, okay. However, take note, when we talk about 1 mole, we are always referring to 6 times 10 to the power of 23. Okay, 6 times 10 to the power of 23 of oxygen, 6 times 10 to the power of 23 ammonia, water, so on and so forth. Okay, at this point, you should realize that formula is very important. Okay, it is expected of you to know the formula. Okay, fill in the blanks for this part inside your notes. Okay, so check your answers. Do you get these numbers? Okay, Mr and molar mass, they are the same thing. One has unit, one no unit. So take note. Hey, you can do this in your own house. Okay, 1 mole of copper atoms is heavier than 1 mole of magnesium atoms. Okay, if you think it's true, you stand up. If you think it's false, you sit down. Okay, so true or false? So first of all, ask yourself, 1 mole means 6 times 10 to the power of 23. So 1 mole means you need to ask yourself, what is the molar mass? Molar mass of copper is 64 grams per mole. Okay, then 1 mole of magnesium is 24 gram per mole. So if you look at this, you should be able to see very clearly which one is heavier now. So we compare molar mass. Answer is true. Okay, so indeed, 1 mole of copper atoms is heavier because 1 mole molar mass is 64, magnesium is 24. Okay, try another one. Okay, 1 mole of copper atoms is heavier than 1 mole of Fe atoms. Both are using 1 mole. Both are looking at 6 times 10 to the power 23. Okay, we don't need to care about that. Once we see 1 mole, we compare molar mass. So answer is true, because 1 mole of copper atoms is 64 gram, whereas 1 mole of iron atoms is 56 gram. Okay, so let's take a look. Okay, so at this point of time, mole is just another quantity. They are the same as pair, dozen. Okay, they all represent a fixed number. Okay, and of course they are directly related to the mass. Okay, so if you take a look at this bottom part of this picture here, okay, for example 12, or for example dozen. Okay, we are looking at dozen. Okay, so 12 paper clips versus 12 blocks. Okay, so the quantity is the same. Okay, we are comparing dozen, right? The quantity is the same, both are 12. Just that blocks, right, they are heavier. Paper clips are lighter. Okay, so this is the same as just now the question on 1 mole of copper versus 1 mole of iron. Same quantity, but of course they have different mass. So after learning all this, try to complete the next page of your notes, page 7. Okay, so complete then. Molar mass is the mass of 1 mole of any substance. It can be any substance like iron, calcium, chlorine, sodium bromide, anything. Okay, so 1 mole refers to 6 times 10 to the power 23. Okay, so we seldom use that number. Okay, we often use mole. Okay, because mole is easier to count. All right, so let's take a look. So if I have 1 mole of iron, okay, it's 56. Okay, because that's the molar mass. If I have 2 moles, if I say, okay, now we have 2 moles of iron. So how to calculate will be 56 times 2. Okay, if I see instead of 2 moles, I have 0.5 moles. Okay, 0.5 moles, what I do is just 56 times 0.5. Okay, if I tell you 1 mole of iron is 56, but now you are given 14 gram. You are given 14 gram. So in this 14 gram, how many moles of iron will there be? Okay, how many moles of ions are there? All right, so what you will need to do is you do your calculation, okay, and you will get 0.25. Okay, then let's take a look at calcium. 1 mole of calcium is 40 gram. 1 mole is 40 gram. So if I have 0.25 mole, what is the mass? Okay, I repeat, 1 mole of calcium is 40 gram. Now you only have 0.25 moles. What is the mass of this 0.25 mole? So what will you do? You use 40 times 0.25. Okay, now, okay, let's try the next two. Chlorine. Chlorine, what is the formula of chlorine? Remember, chlorine gas. Chlorine always exists as Cl2. Okay, so you need to know the formula. Without knowing the formula, your molar mass, you cannot calculate. Okay, so 1 mole of chlorine is 71 grams. Cl2. Write down the formula Cl2. Okay, and then you're given 1.42 gram. So 1 mole is 71 gram. You're given 1.42 gram. How many moles of chlorine are there? Okay, so what you will do is you will calculate 1.42 divided by 71. You'll get this. Okay, then for sodium bromide, what is the formula of sodium bromide? It's NaBr. Okay, so write down NaBr inside your notes. Okay, so for NaBr, formula is 23 plus 80 for your bromine, and you get 103. So 1 mole is 103 gram. 1 mole is 103 gram. You are given 1.55 moles. So the mass will be 103 multiplied by 1.55. Okay, you'll get this. 160 grams. Okay, so this rightmost column here, okay, the unit is gram. So actually, okay, what is the formula, okay, to calculate for all substances? So I can give you molar mass, I can give you amount. Okay, for example, iron. Okay, I can give you molar mass, amount, and I ask you to find the mass. Or I can give you the mass, you know the formula for iron, which is Fe, you know the molar mass, and then you can calculate the amount. Okay, so actually there's a formula. Okay, and the formula, okay, don't memorize. Okay, don't memorize. Okay, if you are able to tell me that 1 mole of iron is 56, you can calculate already. Okay, so this is actually the formula, mass over molar mass equals to number of moles. So if you ask me whether I need to memorize this, you don't really need to, as long as you understand this concept called molar mass. Okay, so 1 mole is 56. 2 moles multiplied by 2. 3 moles you multiply by 3. Okay, and from the mass you can calculate the number of moles, vice versa. Alright? Okay, so in your notes, okay, there are some questions for you to try out without looking at the answers. Okay, try the questions yourself first. Okay, so using this formula, mass over molar mass equals to number of moles. Okay, so question 1a, you must know the formula. You don't know the formula, you cannot calculate the molar mass. Okay, so molar mass will be 17 gram per mole, because molar mass is the same as your relative molecular mass. Okay, so if you calculate 8.50 divided by 17, you'll get 0.5. Leave your answers in 3SF. I repeat, leave your answers in 3SF. Okay, so for question 1b, same thing. What is the formula of magnesium nitrate? It's Mg bracket NO3 2. Okay, so if you calculate the MR, you'll get this. And then number of moles, you're given 14.8 grams. 1 mole is 148 grams. 1 mole is 148 grams. And you are given 14.8 grams. So how many moles are there? Okay, so if you use the formula, you'll be able to get this 0.100 mole, 23SF. Okay, now try 2A and 2B. Time yourself in 4 minutes. Okay, so for question 2A, now they want you to find the mass. So you're given the number of moles, you need to find the mass. So what is the formula of oxygen? This you need to know. Oxygen is always O2. Okay, O2 so that they are stable. Your dot and cross is O2. Okay, so mass of 1 mole of oxygen is 32 gram. 1 mole. 1 mole is 32 gram. You are given 0.25 mole. So 0.25 multiplied by 32, you get 8 grams. Okay, so 0.25 moles is only 8 grams. Okay, 3SF. Okay, likewise, carbon dioxide. Okay, formula given to you, very nice, but you should remember CO2 is 12 plus 32, 44. Okay, so 1 mole is 44 grams. You're given half a mole, so half a mole is only 22 grams. Okay, so to conclude, alright, this is the formula that we have learned so far. N refers to the number of moles. Okay, mass over molar mass. Okay, number of moles is always referring to amount. Okay, so maybe you want to write down here inside this number here, okay, is equivalent to amount. So when we find out the amount of substance, we are referring to a number of moles. Okay, so we have finished AR, MR, percentage, and we just concluded what is mole and what does molar mass mean. Okay, now all these help us to find out what is the formula. So formula of NaCl. Okay, we know it's NaCl because we know from the charge. But actually before this, with long time ago, people don't really know the charge. They don't even know that it exists. Okay, so what they do is they do experiment and they calculate by ratio. Okay, so we're going to take a look at how these mass help us to find the ratio. Okay, so we know about molecular formula. Okay, molecular formula is chemical formula. For example, NaCl. Okay, NaCl formula for sodium chloride. What is the formula? What is the molecular formula for water? H2O. Okay, so there is this new term called empirical formula. So what does empirical formula mean? Empirical formula, or the word empirical, means data. Okay, empirical data means data from experiments. Okay, so we're going to find out what's the difference between these two. Alright, so let's take a look first. I have 3 compounds, water, butane, and hydrogen peroxide. Okay, so for empirical formula and molecular formula, okay, I want you to compare, note the difference. Molecular formula is the one that we've learned so far. Okay, molecular formula is the one that we learned so far. Full structural formula is the one that shows the bonding. Okay, it shows how they are bonded. Okay, how many covalent bonds and which atom is bonded to which atom. So if you take a look at hydrogen peroxide, okay, it shows that the oxygen are bonded together, and then each oxygen is bonded with one hydrogen. So you can see from here. Okay, so these are the bonds. Empirical formula, what do you notice? For example, butane is C4H10. Okay, the actual formula is C4H10, actual. But empirical is C2H5. So what do you notice? Hydrogen peroxide, actual formula is H2O2. But now it's HO. So what do you notice? HO is the simpler ratio, right? C2H5 is the simplest ratio for C4H10. Okay? So empirical formula shows the types of elements present and they are in the simplest ratio. So what it tells me is that, okay, butane, right? It contains carbon and hydrogen. It tells me what it contains. And this is the simplest ratio. Whereas for molecular formula, it tells me the types of elements and the actual number. So actually, butane got 4 carbon and 10 hydrogen. So this is the actual number. Then the full structural formula, as it shows here, it just tells me how they are bonded. Okay. Empirical formula is from experiment. So I do experiment and then I realize, okay, this is the percentage composition. Percentage composition, this is the simplest ratio. So let's try. For example, okay, methane. Methane is CH4. Okay, so empirical formula, simplest ratio is also CH4. Okay, now ethanoic acid is C2H4O2. So what is the simplest ratio? So 242, simplest ratio will be CH2O. What about glucose? Glucose actual formula is C6H12O6. Empirical formula will be CH2O. Okay, so empirical formula is the simplest ratio of the elements. And if you notice, molecular formula and empirical formula can be the same. Okay, so this is for methane and formaldehyde. Okay, so these two, they have the same molecular formula and empirical formula. Because the molecular formula is already the simplest, cannot simplify it anymore. However, if you notice, different compound can have the same empirical formula. Okay, if I simplify all of them, I can have different compounds with the same empirical formula. Okay, so empirical formula just tells me, give me the information about the types and in what percentage or in what composition, what ratio. Okay, now I'm sure you know her, or maybe if you don't know her, you might know him. Okay, so Lisa stands for L, M stands for messy. Alright, so there are 10 Lisas and 2 messy in a compound. So what is the empirical formula of the compound? Empirical formula. Empirical formula is simplest ratio. So if I simplify them, 10 is to 2, simplify will be 5 is to 1. So the answer is L5M. Okay, L10M2, this is your molecular formula, the actual number. Okay, so we try, right? Now, for example, okay, so Lisa is 200 kilograms, Messi is 100 kilograms. Okay, the values are just an example. I'm not saying that Lisa is 200 kg, yeah? Okay, so for example, Lisa is 200 kilogram. One Lisa is 200 kilogram. One Messi is 100 kilogram. In this compound, this unknown compound, I have 2,200 kilogram in total. 2,200 kilogram. Okay, out of this, 2,000 is because of Lisa. 200 is because of Messi. What is the empirical formula of this compound? So I've done an experiment. Okay, so step 1. Okay, Lisa contributed 2,000 kilogram. Messi contributed 200. One Lisa is 200. From the first statement here, one Lisa is 200. One Messi is 100. Okay, per unit is one of them. So 2,000 kilograms is contributed by Lisa. One Lisa is 200. How many Lisas are there altogether? 10, right? One Messi is 100. Okay, 200 kilogram is contributed by Messi. So how many Messis are there? 2. So what is the ratio of Lisa is to Messi? 5 is to 1. Simplify. Okay, so the simplest ratio is 5 is to 1. So empirical formula is L5N. So this is how we get empirical formula. This is how we derive the formula from experiment. So from experiment, we can get the simplest ratio. Okay, we can identify what are the elements and the ratio to which it contains. Okay, so chemistry, we don't have Lisa, we don't have Messi. Okay, but we have many other elements. Alright, so the steps are the same. Okay, we always find the mass of contributed by that particular element. Okay, then we need to find out, okay, what's the unit? How many units are there? Okay, number of moles. Okay, then we compare the mole ratio. Okay, to understand the mind, we try examples. Okay, so first of all, okay, you are given this example. Okay, and then they are telling you that this magnesium is being burned in oxygen. Okay, so what you need to do, first thing is you need to identify what are the elements. Okay, so for example, you have magnesium. In this case, you have oxygen. Okay, so mass of magnesium is 0.48. And then when you burn to produce magnesium oxide, okay, let's say you don't know what is the formula. At this stage, you don't know what's the formula. Okay, but you know that there is oxygen. Okay, when oxygen is added, the weight becomes 0.8 gram. Okay, when oxygen is added, the weight becomes 0.8 gram. So, mass of oxygen is 0.32. Okay, so what you need to do is you need to have this table. You must know how to draw this table. Okay, this table is extremely important. Okay, you must know how to draw this table. Okay, I put a star here. Alright, so magnesium. Okay, we know that the total compound magnesium is 0.48 gram. Okay, and out of this 0.8, 0.48 is magnesium. So which means the remaining mass is contributed by oxygen. Okay, so one magnesium is 24 gram. Remember, one magnesium is 24. Okay, we are looking at empirical means simplest. Okay, take note. Empirical means simplest. So what is the relative atomic mass of oxygen? One oxygen, 60. Okay, only one oxygen. So what is the number of moles? Number of unit. Okay, one magnesium is 24 grams. If I have 0.48 grams of magnesium, number of moles is mass over your AR. Alright? Same for oxygen, 0.32 divided by 16 equals to 0.02. Mole ratio, 1 is to 1. So simplest ratio, 1 is to 1. Formula is MgO. Pause the video, take some time to understand. Compare this slide with the Lisa slide. The steps are the same. Total 0.48 is by magnesium. One magnesium is 24. So how many moles of magnesium are there? How many moles of magnesium are there? Then you compare the ratio. This last statement is 1 mark. Okay, this last statement is 1 mark. Alright, so this table usually is 2 marks. Okay, 2 marks. Then this last statement here is 1 mark. Okay, so try example 2. Alright, so for example 2, okay, same thing. Okay, you're given this compound, and for this compound you are given 0.520 gram of potassium, 0.640 of oxygen, and then 0.473 gram of chlorine. Okay, so there are a total of 3 elements. Okay, if you realize one thing to note, students, okay, this 1.633, okay, this is the mass for the whole compound. Okay, and then if you add them up, okay, if you add this 3 number up, okay, it should be this number as well. So if you add this 3 number, it should be 1.633. Okay, so they are given 3 elements. Okay, so fill in the blanks. Step 1. Okay, draw the table. Okay, fill in. So potassium is 0.520, oxygen is 0.640, chlorine is 0.473. Okay, and we are looking at one atom. Take note. Okay, I want you all to put a star here. Okay, put many stars here, highlight, circle this word. Take note, it's always one atom. Okay, so 1 AR, okay, for potassium is 39, oxygen is 16. Take note. Okay, this is the part that students will get it wrong. Alright, chlorine is 35.5. We are always looking at just one atom. What is the mass of one atom? Okay, reason being, empirical means simplest. Empirical means simplest. Okay, so without looking at the answers, I hope that you have already calculated the moles. Okay, 1 potassium is 39, 0.52 gram, how many moles? Okay, you should be able to get this, mass over molar mass. Okay, so after you've gotten all these, you need to find the mole ratio. Now, if you take a look at this example here, the mole ratio is not easy. It is no longer 5:2:5, okay, or it's no longer 10, okay, it is no longer 10:2:10. Then you just simplify, become 1, okay, it is no longer 10:2:10. Then you just simplify to become 5:1:5. It's not that simple, okay. So actually, to do this, okay, the math is to divide by the smallest number. I repeat, the math is to divide by the smallest number. Okay, so if I divide by the smallest number, the ratio is 1:3:1. Okay, so simplest ratio is 1:3:1. Alright, so it's like your math, you have these three numbers as your ratio. So all you need to do is to divide by the smallest number. Okay, so if you really cannot see it, you just see it as if this is 5, for example, this is 5, 5. Okay, and then this is 10, and then this is 5. So what you do is you get 1, 2, 1, right? How do you get 1, 2, 1? Because 5 is the smaller one, you divide by a small number. 10 divided by 5 is 2, 5 divided by 5 is 1, so 1, 2, 1. So same thing, this one, divide by the smallest number. Okay, I divide by the smallest number, this 0.04 divided by smallest number is 3. So simplest ratio is 1:3:1. Now this table, only 2 marks. You need to have one more mark, which is your statement. So the empirical formula is KClO3. Or if you write down KO3Cl, does not matter. Okay, so at this point does not matter. But usually oxygen is at the back. Metal is in the front. Okay, if you take a look at this, potassium is in front. Okay, can? Let's try the next example. Okay, the next example is percentage by mass. Okay, so in this case, what they are giving you is percentage by mass. Okay, they tell you out of this 100%, okay, out of this 100%, 40% is sulfur, 60% is oxygen. Actually, right, it's the same. What do I mean by the same? You're just assuming this unknown compound is 100 grams. 40 grams is by sulfur, 60 grams is by oxygen. So the percentage sheet doesn't matter. Okay, method is the same. Write down your table. I need to see this table. I need to see the headings. Sulfur is 40%, oxygen is 60%. Atomic mass of sulfur, you look at your periodic table, is 32. Oxygen, we are looking at 1 oxygen is 60. Steps are the same. Okay, instead of percentage, you see it as gram, 40 grams, 60 grams. Okay, so 1 unit of sulfur, 1 mole of sulfur is 32. Now you are given 40 grams. How to do it? Mass over molar mass. Okay, you get 1.25. Oxygen, 60 divided by 60, you get 3.75. So I want to calculate ratio. I divide by the smallest number. Okay, if I divide by the smallest number, I will get 1:3. So this unknown compound, the empirical formula is SO3. So this last statement is 1 mark. Okay, can? So it's the same thing. Now for empirical formula question, you have to aim for full marks because you can work backwards. Okay, what do I mean by work backwards? Now I want you to go and calculate SO3. Go and find out what is the MR. Okay, go and find out what is the MR. And then go and find out what is the percentage composition of sulfur. Go and find out what's the percentage composition of oxygen. You realize if you work backwards, you should be able to get this. Okay, so this is a way to check your answer is correct. Okay, can? So try example 4 now without looking at the answer. Okay, it's the same thing. Draw out the table to help you in your calculations and presentation. So first thing is I have 30.4% of nitrogen. Okay, step 1, fill it in. 69.6% of oxygen. Atomic mass. Okay, I repeat, one atom. Nitrogen is 14. Oxygen is 16. So I will need to calculate the number of moles. Okay, so if I calculate number of moles, mass over molar mass, okay, I'll get this. Mass over molar mass, I'll get this. Alright, so this is a bit difficult for me to see the ratio. Okay, some of you might be able to see is 1 is to 2. But if I cannot see it, I divide by the smallest number, 2.17 divided by 2.17. Okay, and I'll be able to get the ratio of 1 is to 2. So from this experiment, okay, I am able to deduce that the empirical formula is 1 is to 2. Okay, so this is 1 mark. Okay, formula is NO2. Okay, now on your notes page 11, alright, sometimes, okay, you can get this kind of ratio. Okay, I want you to put star, 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 circle, circle, or maybe you put post-it or whatsoever. Tell yourself that sometimes this number we don't just divide. Okay, we don't just divide to get whole number. In fact, we multiply. Okay, why we don't divide? Because if you see here, for example, if I see here is 1 is to 1.25. If I divide smallest number, I will get about 1 is to 1. Actually, it's not very accurate. Okay, so it's not very accurate. So actually, right, if I multiply by 4, the ratio is 4 is to 5. Okay, so it's not really 1 is to 1. So that's why we don't simplify by dividing. So these are the 4 sets of number. So for example, you see this 1 is to 1.5. Okay, if I say what is the simplest ratio, you will tell me it's 2 is to 3, right? You wouldn't tell me it's 1 is to 1. Why? Because 1.5 round down also not very correct. Round up also not very correct. Okay, so what you do is you multiply to get 2 is to 3. Okay, likewise for example 1.3333. Okay, if you want to round it down to 1, also like not accurate at all. So what you do is you multiply. So these 4 sets you multiply instead of divide. Okay, so you write this down inside your notes. This part here very important. Okay, students tend to forget. Alright. Okay, now then actually how do we get molecular formula? Empirical formula is the simplest, right? So how do we get molecular formula? So molecular formula, I can calculate from the empirical formula together with the actual mass. Okay, together with the actual mass. So we will see some examples. Okay, so for example, hydrogen peroxide. Okay, molecular formula is H2O2. Okay, so simplest ratio empirical is HO. So experiment tells me that empirical is HO, but when I measure it, right, when I measure the substance, I'll get 34. So what does this mean? So this means that this is my actual mass. This is my actual mass. So this means that this empirical formula, I need to multiply by 2. I need to multiply by 2 to get this. So molecular formula is the actual one. Okay, so let's try some examples. So glucose, empirical is CH2O. CH2O. However, when I really measure it, when I measure 1 mole of it, I measure 1 mole of it, I get 180. But if I use this empirical formula, the value does not tally. Okay, so actually actual mass is 180. Molecular formula must be greater than this. So what I do is 180 divide by 30. My molecular formula is actually 6 times of this. Okay, so empirical formula is from the data simplest ratio. Then I need the actual mass to really find out what is the actual correct molecular formula. Okay, alright, so molecular formula is a multiple of empirical formula. Okay, it can be just where n is 1, 2, or 3, so on and so forth. Okay, so let's try. So for example, propene, the simplest formula is CH2. However, when I do my experiment, I realized that the actual mass is 42. 1 mole is 42. Okay, so what do? I assume that it's CH2, okay, and then I bracket to form multiple of n. I don't know how many times more. Okay, empirical formula from here, empirical formula tells me that it's CH2, so it's 12 plus 2. So it's 14. Okay, so empirical formula tells me it's 14, but actual data tells me it's 42. So 42 divided by 14 is a multiple of 3. So the actual formula is C3H6. Okay, so I want you all to try example 2 on your notes, page 12. Okay, so in this case, we are given this unknown compound which contains carbon, hydrogen, and oxygen. Same thing, draw out the table with the headings to help you in your presentation and calculation of your working. Okay, so the mass of each element, follow the question and fill it in accordingly, is 40, 6.6, and 53.3. Alright, and for each element, the atomic mass is 12, 1, and 16. Okay, from this mass and atomic mass, calculate the number of moles, or rather the number of units. Okay, so 40 grams contains about 3.333 moles of carbon, okay, about 6.6 moles of hydrogen, and about 3.33 moles of oxygen. So from here, actually you can see that the ratio is about 1 to 1. Okay, but to see how it works using working, we divide by the smaller number, okay, which is 3.33 here. So if I divide, I'll get about 1 to 1. So the simplest ratio for this compound X is 1 to 1. Okay, and the last part is to write down the statement, which is CH2O. Okay, oxygen usually is the last part. Alright, in this question, they ask for molecular formula. They don't want empirical. So this is not the final step. Okay, we still have one more step. Okay, from here, empirical formula is CH2O. Okay, and we calculate that the mass is 180.1. Okay, the mass is 180.1, so it is about 3 times of the empirical formula. Okay, so you should have your molecular formula to be 3 times of empirical, and you get C6H12O6. Okay, so the molecular formula is C6H12O6. Alright, so this is how we calculate the molecular formula from the empirical and the mass. Okay, so far we learned empirical formula and molecular formula, and we see how they are related to each other.